So I started this out the other day showing the 3 different regressions. And on the board also.
Sir, we can't see it.
Oh.
Can you change, please?
Okay. Other than his order of he does mx plus b, but we do a plus bx. We did our regression, and I'm going to show again how to do the mathematics, but if you don't really care about the mathematics, you can always find that best fit line that goes through your re-expressed data. You know, when we logged list 2? Remember when we logged list 2?
Yes.
And create another line through that? You could always say y hat will be equal to 10 to the a times 10 to the bx. That, you know, this is exponential because the x is in the exponent. That's exponential. We haven't done power yet. We're going to do that today. And the mathematics is probably the hardest mathematics you'll have in this class all year. But the good news is you don't really have to know it, but the teacher and me is still going to go through it. And that equation turns into a to the x, a to the, not a. It was 10 to the a. This time it's x to the b. Since b is just a number, this is just like an x squared, x to the third, x to the 5.175. Those are all just exponents that are called powers, so we call this the power function. Power function can look like exponential. They look almost the same. And you're going to find out how we know the difference, hopefully. All right, so open up your calculator. My pen died. What was the last data set we looked at? It should still be there. Ladies, calculators. Last data set. Was this the last data set, or did we get past that? Or was this your last data set? We're past that. Died. Let me quit using my pen. Right here.
Yes.
All right. Did we get through the final equation?
Yes.
If we did, then someone can tell me what it was. What was our final equation? Without looking at the paper, just look at your work or your calculator. Should still be in your calculator. I didn't know if we finished it.
Wait, guys, are you sure we finished it?
I wasn't sure.
I don't think we did.
Okay. So, all right. So let's go over here. There's the original scatter plot. Can we agree with that?
Yeah.
Then you did the best fit line through it. Does those numbers look familiar? Do you remember what we said, that these 0.997 means it's a good strong R? Very strong? And R squared is 99% of the data has the Y values that is explained. It looked very good, didn't it?
Yes.
What do we do after that to find out if it's truly linear, even though I think it is? It looks good. What kind of plot must I do? Residual. Now, you don't have to. You could do, we did this. We did the differences and got all these differences was 0.2. Then we did the differences here. The differences didn't look as good as the ratios. All the ratios came out to about the same. What did the ratios come out to? 0.1s? I wish I had it memorized. Just somebody do 1.18 divided by 1.08. That was what?
1.09.
They were all about that, remember?
Yeah.
So I told you that if that happens, all your ratios are about the same, it's probably what? Exponential. But anyway, the AP test will never make you test the data. The smell test is always this beautiful residual plot, which you do only after you create the best fit line right here that goes through this data. Actually, when you draw it, it did look pretty good. It did look pretty good. And we had a good equation there. But the residual plot stank. It smelled bad. That's the smell test. That meant the data was not linear data. So we all did that, right? What was the next step we did, or did we leave it there? Well, hopefully what we did was, let me go down here. What I would want you to do, let me see if this will let me erase. I would want you to go back to list 3 again, please. Yes? Yes? I'm recording this lesson for you guys, so... Is YouTube back up and running?
It's back.
All right. Holy cow. All right, next time that this many people is going, you all have to go. I'm kidding. Why didn't you give it to me at the beginning?
I didn't know until I saw hers.
Yeah, I bet someone gave you a copy and you said, I'm going to go to. You better want to go to this school.
I promise.
All right.
This is the first one that I've gone to.
Okay. You too, guys. Hey, you got a lot of work to do. You too. Are you really thinking of UT Austin? If you're just going for fun, have you applied yet?
Going to A&M UTRGV.
That's UT Austin, though, isn't it?
This is my office.
But you said, oh, okay. Wait a minute. I didn't sign the Nicole and Denise? No, I did. Oh, you handed it to me with the other people's? Oh. Wow.
Party, sir.
Wow. Can you guys come over here? All right, so you got to No, we got to do this. I'm recording for YouTube. That's been there for like days. I figured if I left it there long enough, it would walk home to you.
I bought new clothes and everything because I couldn't find anything.
I almost was going to sell it. I said, how many days do I got to stare at dirty clothes? All right, guys. You guys are going to get the special 1-on-4 treatment. Everybody on YouTube is going to wonder, what's going on? A class of 27 turned into a class of 4 because everybody's on a trip or going to go visit UT Austin. It's crazy.
I bet half those people aren't even
No, well, no, actually, they only accept 30%. So here goes. In your L3, please tell me you at least have the original data in your calculator. All right, you can delete your residual data because we don't need it now. I need you to log list 2. Log list 2. And numbers will appear. Now, don't forget, we still have our list 1 in our calculator, right? List 1. Now, I want you to go back to your scatter plot. And I want you to look at list 1 versus list 3. And I know the original looked pretty linear. Does the new one look just as linear, if not better? No calculator?
I don't have it.
Slide over. Share with Thomas. I was going to say Noah. Thomas has the good looking hair, you know that.
I forgot my phone, sir.
So just tell me, is the scatter plot at least as linear as it was, or even maybe more stretched out, look better linear? I think I remember it looked a little better. But what do I know? The original data looked wonderful. I can't even see a curve in there unless I zoom in a lot and then I say, oh, wait a minute, maybe I do see this slight curve here. Maybe. But it doesn't matter. You say it's more linear, so I'm going to run with it. So what I need you to do now is to now clear your screen and do stat calc 8, list 1 versus list 3. And I want to see that line. Does it now go through this new stretched out data? and tell me what r is and what r squared is.
Wait, sir, do you want store this function in y2 or in y1?
You can store in y1. We don't need that original y1 any longer.
Wait, sir, how do you do all that? Because I'm getting the part where you just get the stat and all the r's, but after that,
Well, that's all I want. I want to see that right now.
okay.
So what was r?
Oh.
As I recall it,
0.99.
0.99 what?
4.
994?
Oh wait, R is 0.997.
No, that's pretty high, isn't it?
Yes.
What's r squared?
0.994.
I'll bet you any money those are probably higher than they originally was. Let's see. 997. No, that's the original, isn't it?
Yeah. Yes.
You didn't do list 1, list 3.
You showed me last time, but
List 1 and list 3. List 3 had the logs of list 2, remember?
It's
Yeah.
0.999
No.
That's what I thought. R was 0.999?
Yeah.
on both of them.
I thought so because I thought they had more nines. They're better than the other one was.
Oh, yeah.
Which is making me think, maybe it is exponential. Now, you have an equation written, right? And some of you paste it. You could have pasted it. You didn't really have to. You could have graphed it. You didn't have to. What was that y hat equal to? What was at least, tell me what a is. You still have it on your screen, some of you.
Negative 3.29.
Give me a couple more decimals.
8 and 9. Is that all or more?
That's good. And what was b?
1773.
And that was x, right? So you agreed it went through that data pretty good. You didn't have to look at it, but you did. I know you're dying to see it. That line is going to be used to make the curve. So now go back to stat plot and turn list 1 and list 2 back on and look at your original. And you're going to notice that the line disappears. It's not really through that data anymore. That's okay. It's not supposed to be through the original data right now. This line was the line through the re-expressed data because you actually logged list 2, remember? But we're going to use it. So I'm going to show you the mathematics in a minute, but right now the shortcut was this. Go to y equals, go to y2, and you're going to type in 10 to the a, negative 3.2989, times 10 to the b x, which is 0.1773x. And now go ahead and hit graph, and magic should happen. You use the expressed data line to create the exponents on the tens, and it should go through pretty. Does it go through nice and pretty? Remember, your original data is on list 1 and list 2.
Oh, the line's not supposed to be here?
Yeah.
That original line won't appear because that was with logs. But this function should appear. Does this one appear on your calculator?
Line 1 and 2?
Line 1 and
Well,
3, right?
you were supposed to do 1 versus 3.
Okay, yes.
And that is the data that is in, this is list 1 versus list 3. This is using these numbers in this equation. Did anybody get it to curve fit?
Oh, I know I missed it.
Did you get it to work, Lauren?
No, Dean and I kind of have the same problem, but I think you figured it out someone else.
Okay, so I'll give you another minute before I jump in
It's
there.
supposed to-
You get it, Dean?
Yeah, it now fit it, right?
Yeah.
Now, and that's Y2, right?
Yeah.
Y2 is being graphed through those dots. Now, it still looks kind of linear, but it really isn't. It's exponential because you graph this. That's an exponential function. If you hit trace and press the up button one time, make sure you're on that curve, you will notice you're tracing an exponential function. So if I ask you to predict, interpolate the value 8.1. Could you find it? 8.1? Hit trace, make sure you're on the function y2, and just type in 8.1. And you'll give me a number that's probably between these two numbers. I'm sorry. Yeah, you will.
Yes, 8.1. X equals 8.1.
And what do you get for y?
0.13. 98.
0.13 or 1 point?
1.1398.
Yeah, perfect. So you're allowed to interpolate values within your data. You're not allowed to give me an answer for x equals to 3. You can do it. You can use your trace and go to 3, but it's not a good answer because it's off the data. Okay? That's called extrapolate. And that's not, it's very dangerous to extrapolate way away from your data. Are you two okay over there?
I still couldn't get the one.
Yeah, the line won't appear.
Well, let's see if there's another one for us to do here. I don't know if the next problem. Actually, I don't know. My iPad doesn't. Oh wait, it moved there. Okay, there it goes. Do I have another data set? I'm not on the last page. Maybe my work went. Oh, that's this. It's right here. This is it, right?
That's the problem we're doing right now.
Okay, good. I thought I lost it. Oh. It did go finally, I think. I don't know. What was I on? Wasn't on this page. All right, so I don't think he has another problem, so let me move on to the topic of power, and then we'll do it together. Make sure we do one of those good. And before I move on, your notes has all the steps for exponential regression. So you can do that same problem over again, and you can follow all those steps. Or let me see if I can insert that. Okay, good. I'm going to make up an equation. Let's pretend that you had data, and again, you put it on the screen, and it went through your revised data. And the equation came up was, why do I keep picking up my pen? It died. I just charged it up today, too. It was really weird.
Do you want a stylus?
No, my finger will be an ugly thing, but I don't know if a stylus works on iPads, does it? Try it. Thank you, Lauren.
I'll do this side.
Oh, I got to, oh, that's right. Okay. Yeah, these are usually fat, almost as fat as my finger. So you got y hat, oh, yeah, it's hard to write.
Oh, sir, I got it.
Worked finally?
Yes, it's because I just put 10 to the power of y1 instead of
Okay.
putting it.
Oh, okay. So if that's the equation that came up that went through the re-expressed data that looked really good, but the curved data looked like this. That's my original. So the problem is we go back to our screen, and I told you we had this fancy formula, but let me show you the math behind it. The reason that line did not go through this original data is because you're really looking at this. Log of y hat equals to 2 plus 3x. That's what you're really looking at. So mathematics says I got to get rid of the log, so I exponentiate both sides. And when you do that mathematical, the 10 cancels out the word log. The 10 to the log power cancels out, just like the log to the 10th power cancels out. They're inverse of each other. So that just leaves you y hat, which is the equation that I want, equals to, now look at this exponent. It's got two exponents being added together with one base, which meant it looked like this. Two bases multiplied together, one with the exponent of the 2 and one with the exponent of the 3x. That's where it came from. But you're allowed, once you get this equation, you're allowed to memorize y hat equals to 10 to the a times 10 to the bx. And then you got it. You don't have to know the mathematics to do it. I just teach you the mathematics, but I do understand that not everybody wants to play that game, okay? Now, what we're going to do, so I'm giving you a preview, power. That was exponential. This is power. And let me share with you what it does. Let's pretend that I had this weird data. Original data was curved. And exponential doesn't work. I tried it. Exponential came out and it made it curve this way instead. Oh, well, that didn't straighten it, did it? So my next guess is power. So if your y hat was sitting at 2 plus 3x again, and I need you to realize that where did it come from? It came from logging both the x and the y. Logging y equals to 2 plus 3, logging the x's. So if we do power, we're going to log list 1 and we're going to log list 2. That's going to be the new data. When you log list 1 versus log of list 2, even this curved data, whether it looks like that or looks like that, it will straighten out when you log them both and you look at that scatter plot. And you say, wow, look at that. I logged them both and it became very linear, and it wasn't linear before. I could really tell it had a curve. So that equation is my y hat that is listed right here. But where did it come from? It came from logging both. So now the hard part is, how do I get log out of there now? What did I do before? I exponentiated. This time, the 10 cancels out the log. I still got y hat, which is what I want. This time, I still have a 10, but I still have two 10s. One gets the 2. The other gets the 3 log of x. Well, I still have a log in there. But remember the rules of multiplying powers? I'm going to show you the math problem. I'm going to do 2 problems with you. 2 to the 4th times 2 to the 7th is what? You know, come on, what's the rule when you multiply like bases with exponents? You keep the base and do what?
Just add the times.
Oh, 11, right? What about 2 to the 4th, all raised to the 7th power? What's the rule?
2 to the power of 3.
28, that's right. All right, let me ask you something else. When we wrote log of x squared, wasn't that equal to the 2 log of x? In your pre-cal? Yes, that's the rule of logs. You can put the power in front. Well, if the power is already in front, where do you think I'm going to put it? Take a guess. On the x cubed. And now look at it. What cancels out? Please see it, please see it, please see it. Please see it. What canceled out here? The log and the 10, right? What do you see? It happened again. Oops. Britney Spears just hit.
Oh.
Y hat equals 10 squared
2x.
times x to the 3rd.
Wow.
Which was the formula that's on the board and in those notes. That when you have power, y hat is 10 to the a times x to the b. If you look carefully at what we started with, there's the a,
And B.
there's the b. It worked. Now, do you want to do this algebra all the time?
No.
No.
No. Are you allowed to do the shortcut trick?
Yeah.
Yeah. But now, let's talk about power. Okay, and before I do the power here, I'm going to do it with you, because somebody got lost. I won't mention her name. It happens. Don't worry. I would rather a person be lost and raise their hand and say, I'm all messed up. Can we back up 500 steps? I would rather people do that. Because what's going to happen is, if people don't speak up, then you end up being hanging in limbo. Wow, okay. You're wondering why I only have a class of 4. I'm a class of 27.
Where are they?
6 are at Heal 2, and maybe 5 are at another field trip, and then today is UT Austin was here.
Well, you guys are lucky you have extra one-on-one almost.
Almost.
Have a good weekend.
Likewise, now. So, let me take up my calculator. And help me out too. Put it in your calculator fast so you can help me get it in mine, because I'm blind. I'll just erase all my data for now, because I don't need any of this garbage. I should have left in list. I should have put those lists in. I did earlier. I should have put them in, saved them like in list number 10. I could have gotten them back.
Do we,
You already done?
Yeah.
Oh, cool. Help me out.
1.5, 2.6, 3.9.
Oh, I didn't take it. It didn't take the 2.6. I hit the enter. It really did.
Oh, you put 2.9.
Oh. 2.6, right?
Yes.
And then
you put 2 dots.
What the heck? It's so sensitive. It says 2.6. Oh, it's
Okay.
extra dot. 3.9?
Yes. 5.5. 7.2. 7.7. And 9.4.
Okay. And the other ones?
1.9. 4.6. 8.8. 15.3. 23.5. 26.2.
Oh. 26.2.
And 36.1.
36.1.
Oh, sir.
Yes.
You put 1.3 instead of 15.3
Okay, and where at?
at the third on, no, fourth on L2.
Will be what?
It's 15.
Yeah, 15.
15 point to the 5 just didn't come out. I didn't notice it. Thank you. So let's pretend that I do my scatter plot. Well, I'm not going to pretend, I'm really going to do it. List 1 and list 2. And that's already there. Zoom 9. And I say, I'm not even going to waste my time doing linear check because I can see some curvature. We'll at least assume that for a second. Let me get rid of that equation. Still graphing. Still graphing. There it is. Get rid of that junk. So we've already decided it's not linear. The next step was check to see if it's exponential, which it kind of has a curve, doesn't it?
Yeah.
So let me just say it's exponential. Let me see what happens. Stat edit. List 3, I'm not going to do residuals. I'm not doing the best fit line to that data because we know it wasn't right. I'm going to log list 3. Log list 3. Double, oh man, what did I hit wrong now? Log of L3, what's wrong with that?
There's nothing on L3.
Oh, list 2. That's why, duh. Check those values, make sure you get the same ones. Because I always mess up. So I believe it's exponential, so I'm going to look at a new scatter plot, list 1 and list 3, like we did in the last problem. So we're reviewing that last problem because we had some trouble, right? So this is healthy anyway. We're not wasting time. We are being proactive. List 1 and list 3, scatter plot, that's fine. Zoom 9. Did I have it?
L2.
Yeah, you
I was just wondering if I said it. Oh, it doesn't say 3. I thought it said 3. List 3. Now zoom 9. Oh, usually it strengthens it out, doesn't it? It didn't. Matter of fact, it went from this kind of curve to a worse curve,
Yeah.
so it's not exponential. Can we agree?
Yes.
I don't know what it is now. So the next guess is, you try power. There's others, guys. There's square root, there's x squares, there's natural logs, there's all kinds of curves. And in the other packet that you're gonna work together if we have time, in the middle of that packet, there is a square root function in there. So I don't know if you'll catch it. But most of them are exponential or power. Sometimes they're both. Sometimes they could be square root functions and an exponential function, or square root and a power, not
Is this
usually.
the one we're gonna work on?
No, that's your homework. So, what I'm gonna do is, I'm gonna go back to stat edit. Stat edit. And will it confuse you if I leave this as log of list 2 and I put log of list 1 in L4? Will that confuse you?
I'm not.
Because I already have one of the logs,
Mhm.
but I need the x's too. So I could just erase it and do it. It wouldn't take that long, but except for me, it takes long because I make mistakes. So I need the log of the x's as well. So that's going to be the log of list 1. I got to be careful because I want to look at a scatter plot of the log of list 1 versus the log of list 2. So I got to switch them in my head. So I go back to my scatter plot, and turn is already on, but I want list 4 as my x1s, and list 3 as my y's. This was the log of my x's, log of my y's. Now I'm going to hit zoom 9 and see if does that make it more linear. Boom!
Yes.
It's power. It's got to be a power curve. Okay? So I like that. So I'll make my best fit line through that. Here goes. Second quit, stat, calc, 8, L, say it again, L what? L4 and L3. Paste it into bars, y bars, function y1. Calculated, see how strong it is, let's see. Oh sweet, look at all those 9s. That line is strong. That means the curve should be strong. Okay, so now I look at it, looks great. But remember, that's not the original data. That's the transformed data. That's the line that goes to the transformed data, but I'm going to use it. Because that has the A that I need, that has the B that I need. So I go to original scatter plot, turn it back on, list 1 and list 2, list 2, take a look at it, remind me what it looked like. Yeah. Now, are you afraid about that line right now? What's wrong? What happened? Why is that line doing that? That's the line that went through the change data. It's not the line doesn't go through that curve. But I'm going to use that line that still has the same A, the same B. Y equals, I'm not going to do all the mathematics because I know the shortcut. It's written over there. 10 to the A. A is negative 0.0032867. I don't need all those. Negative 0.00.
32.
Zero what?
3286.
Oh, 003. Oh, you're telling me. You're helping me out. 3, 2.
Oh, you missed. You need another 0.
I do. I probably backed over it, didn't I?
Yes. Go back again.
A
Put
0,
32
3, 2,
86
86,
7.
7. That's probably enough, right?
Yes.
Get out of there. And what do I put now? Which one am I doing? Which one? Top one or bottom one? The bottom is exponential.
Oh.
Top one. So it's an X caret B. So you're gonna have to, I can see a 1.60. 1.603. Can you give me one more from your calculator? You can scroll over.
7.6.
Okay, I'll let you put yours in, and the magic is gonna happen. The magic. Boom, boom, graphic cut. Oh, come on.
You got it.
There it goes. There, oh, here it comes. Look at, look at, look at, look at, look at how you can even see it curving up. Look at that. Look at that. You see it? You see the bend? That's curve fitting. So, did you get it this time, Lauren?
I got lines on the calculator.
Yeah, so the log of those
Got it.
Almost, pointed just a little. When is new along this thing?
No,
That was in the other.
no, so you can just go and turn off that, first function. We don't need that anymore. You didn't really need it. You need, oh wait, yeah, it is off. What happened?
I don't know.
Where is that coming from?
I just plugged that in, and then it just,
Okay, let's, this L1, L2?
that's exactly, that line is what we plugged in right now.
Why are you plugging a line? It's,
Oh, I'm sorry, the 10 thing, the 10,
It is, but then
Yeah.
okay, maybe your L1, L2 is not on. Make sure we turn no, you still have L4, L3.
oh, okay.
That's why. So we can quickly do that. Oh, I didn't zoom that. No. Zoom that will take this out. Put it on the screen first before it goes, zoom.
There we go.
Yeah, you got it, you got it. All right, so that's the rest of the lecture notes. And so now, yeah, you got, I guess you could choose whatever packet. I didn't let the other classes work on the homework. I let them do the, I wanted to start working on the other harder ones, because they're more open-ended.
The homework is just R7?
Yes. And it might have an R8 at the end of it too.
So we just put what they are, like answer, so let's say this one's exponential, we would just write exponential.
Is that all it's asking you?
Generate exponential, equations.
Find the new equation. Like the second one that goes to the data, I want that equation.
Oh, okay.
Yeah, it's to be 10 to the A, 10 to the B. Which one are you gonna do?
I don't know, I guess I'll work on the other one. Do the homework.
Okay, I'll put that up there. Because those are more, the homework ones are more simpler, that you won't have as many